Okay, so let me write over here. Let me share my screen. So, so if we have record 1 and length is equals to 20, so address is going to starting from 0 to 19. Okay, now second record, that is R2, and the length is equals to 10 only, right? So it will store from 20th number location to the 29 number location. Okay, is it so? Yes. So in this case, we cannot directly find out this address of ith record, right? We cannot directly find this answer. Why? Because the record length is equal. Then and only then we can directly check the base record. Okay, just give a minute. Okay, so it is possible only when our record length is equal when we are just trying to store it into the particular order, right? So file organization, relative file organization will work when possibly if our record length are equal, okay? So if the record length are equal, we cannot find out the particular address to find out that particular record from that memory, okay? So relative record number is equals to 0, so you can say record zeroth number block I can access. Okay, so records in memory. Now relative record number equals to 1, so record 1 is going to be printed on the screen. Okay, and it is relatively you can say available, like if the 98 number a relative record number is not stored, right? In that case, that memory address or that memory is going to be free and other can use that memory, but 19 number record is going to be stored at the record number 99. Okay, so relatively we can find it. Now this can be used as a relative as well as sequential also. So random access, ease of processing, low overhead, add or delete based on the relative key. Relative key, that means what? So here I can say that relative key equals to 0. So if you want to find out the 15th number record, right? 15 number record. So how you can find? So you can directly find out the key number 15 and you can check the record number 15 from the memory. Now, only disk devices uses this limited to fixed length records. Relative record number must be known in advance to access any record. Now, indexed sequential file organization. So, what is there in this indexed sequential file organization? So, first, what are the benefits of indexed sequential file organization? So, first, it will just provides the fast data retrieval. Mostly records are of fixed length. Index table stores address of each record. So now our index table is comes into the picture, and that table can store the address of each and every record. Now sequential and random access is possible. Now index table is read sequentially to find the address of the desired record. Now how it will use. So advantage is that indexes are small and searched quickly. So disadvantages are extra space for index. So what we are trying to do, like if I'm storing the record 5 at 65 number location, right? Then record number 6 is going to be stored at the you can say 54 number address, something like this, right? So every time how can I find it? Like first record is going to store at this location, second record is going to store at this location. So what we are trying to do, we are just trying to give some address sorry index number to that particular table, like 0, 1, 2, 3, 4. So I'm just concerning with this and this. Okay, this is my index, you can see index table value. Okay, so in this case, index table value can store the relative record address as well as the relative index. So, like using this, I can directly find out the record where this number record or fifth number block where it is stored in the my memory. Okay, so extra space is needed, but this table can store in the smaller area. Okay, though table will require the extra space, but whenever you want to search something, it is directly accessible from that table only. Okay, now how they are going to give you the indexing. Okay, so index to file is like a catalog to library. Okay, so indexed sequential file organization is efficient to use, but in practical where a file may have millions of records, method fails. Right. So based on access type, insertion time, relation time, we have two categories, ordered indices and hash indices. Now, what is ordered indices and what is hash indices? Okay, so ordered indices means what? Indexes are used to provide fast and random access to your records, so you are aware with this. Now, primary index whose search key specifies the sequential order of file. Now, what is key? So, key is you can say the particular integer number which can used to store the index number. Okay. Now, say for example, student file has a sequential order starting from roll number 1 to 70. So, roll number is a primary index. You are aware of this. Now, whole roll number 20 and you get the record directly, right? So this is your order indices. But how we can do it? How we can access that particular data? So secondary index is what and primary index is what? Now we have a primary index starting from 1 to 70. Like we have some roll numbers with us, so we can say that this is our primary index. Now, while primary index provides a sequential order only, there is no any random access. Like if I'm seeing the serial number 1, that means roll number first, whosoever is sitting in my class. Now, index number, sorry, serial number 2, the next enrollment number. It may be the different than your, it may be, you can say the skip from two numbers. Like first roll number is 3017, but second roll number is 3072. Okay, maybe the middle one is in the another class, right? So this is your primary index. Now what is secondary index? So here the search key which provides a random access or different from sequential order will work as a secondary index. Okay, now say for example in student file use a student name as an index which never provides the sequential order as they are sorted rule number wise. Okay, clear? So, say for example, in student file, we use the student name, okay, as index, which never provides a sequential order. So, it will not provide the sequential order. Okay, so as they are sorted a rule number wise. Okay, now what is hash indices? So we require some hashing functionalities to store or to access that file in a particular manner. So why we require hashing first? So internet has grown to millions of users generating a terabytes of content every day. So whenever we have a more than one data with us, and from that data, if we want to find out that particular data, if we want to store that particular data, then how we can do it? So with this kind of growth, it is impossible to find anything in the internet. So it is impossible. Like if we don't have any particular storage technique with us, we cannot find that particular data. So unless we develop a new data structures and algorithms for storing and accessing a data, we cannot find that particular data. Yeah, so the traditional, why not traditional data structure, and why we are trying to discuss the hashing over here to record, to store the record into file, to retrieve the records from the file. Now, traditional data structures like arrays and linked lists, amount of time required to look up an element in the array is either big of log n or big of n. So if array is sorted, then binary search or searched linearly, right? We can search our data either in a binary search or in a linear search. Again, now you are aware what is binary search, what is linear search. Okay, so either case may not be desirable if we need to process a very large data set. Okay, so in either of the cases, we may not be desirable if we need to process a very large data set. So if we have a long data set with us, and if we want to find out that particular data and using the traditional way, it is not feasible for us. Why? Because it will take more time to find out that data. So that's why we require to use this hashing technique. Okay, so therefore, we discuss a new technique called hashing that allows us to update and retrieve any entry in constant time. And that constant time is big O of 1. Now next, the constant time or big O of 1 performance means the amount of time to perform the operation does not depend on data size n. So that means what? So the constant time is equals to, or you can say big of 1. So it means performance means the amount of a time to perform the operation does not depend on the data size. That means here we are not concerning with big of n. That means it is not dependent on the size of my data, but it is dependent on a performance time. Okay, constant time. So pair of the form key as well as the value, where for given a key we can find a value using some kind of a function that maps keys to the values. Okay, so here we have value v and here we have a key k. Okay, so if we want to find out that value, it will not dependent on my size, like value 1, value 2, value 3, right? So that means we must have to take n time. So big O of 3, this is not you can say the performance time. Okay, but it is dependent on the value and the key. That means how we can one integer number which can directly connected with our value as well as the record which can store at that particular location. So the key for a given object can be calculated using a function called the hash function. Okay, now for example, now how we can apply this key, how we can apply that hash function, what is key, how we can identify the key, we'll discuss it. Okay, so till now, any doubt in a hashing? Why we require hash? Okay, so now the concept of a hash table. Okay, so where you can store the value as well as the key in a particular table, that table is known as a hashing key as well as the hash key values as well as the value, or you can say record, and that table is known as the hash table. Now the concept of a hash table is a generalized idea for an array where key does not have to be an integer. Now we can have a name as a key, or for that matter any object as the key. Now the trick is to find a hash function to compute an index so that an object can be stored at a specific location in the table such that it can easily be found, right? So that means, say for example, if I have a 15 values with me, okay, and key is equals to 5. If I have a 16 number record, the key is equals to 6. If I have 86 number record and the key value is equals to 8. Right, so it is something like you can say whatever is the last character, according to that I can store the key values. So if I want to find out the 43 number record, right, at which place I can find? So at the place of 3 I can find out, or at the place of, you can say, index number 3, I can find out the particular address of my record. Okay, so this is the one of the, you can say, one of the trick. You can say for example, we can do it. Okay, so no need to find out the particular, no need to store the to store the particular address of that record. Okay, now what is the, you can say, the different kinds of techniques. So suppose we have a set of strings like a b c d e f g h I that would like to store in a table. So that keys we need to, that values we need to store it into the table. So our objective here is to find or update them quickly from a table, actually in big of one. So in a one search, or in only searching for a one time, I can directly find out that particular record. So we are not concerned about the ordering them or maintaining any record at all. So suppose we have a sign a equals to 1, b equals to 2, up to z, to all the alphabetical orders. So then simply compute a number for each of these strings. So ABC equals to 1 plus 2 plus 3, that is equals to 6. D, E, F. So 4, 5 and 6. Total equals to 15. G, H, I equals to 7, 8, 9. Total equals to 24. Okay, so we assume that we have a table of size 5 to store these strings. Now we can compute the location of the string by taking the sum mod 5. So we will then store ABC in a 6 mod 5. That means 1 plus 2 plus 3. So is equals to 6. So 6 mod 5. Answer is equals to 1. So at the index number 1, we can store our data. Now DEF. So 15 mod 5. Answer equals to 0. So we can store that DEF at the index number 0. We have a GHI. So GHI, that means GHI. 7 plus 8 plus 9. So answer is equals to 24. So 24 mod 5. So answer is equals to 4. 24 mod 5, that means what are the reminder value, that is equals to answer. So 24 divided by 5. So 4 is the remainder. Whatever is the remainder is available with us. So we can store that record into that particular location. So we can store it over here in the 4. Now, so locations 1, 0, and 4 are as follows, something like this. So this is my hash table. So you can say that using this key, I can store it into the particular integer value location in the index twice. Okay. So, so, so till now in this, any doubt in this example? Okay, so now we can immediately compute the location using a simple hash function. So I can say this is my function, mode is the function, mode 5 is the function. Why? Because in a particular data, like this is my data D, right? If I am applying the key plus 1, so what is my data? Suppose 3 plus 1 is equals to 4. So at the location number 4, you can find out that particular record. Now 6 plus 1, 1 is the key, 6 is my data. So is equals to 7. So now at the location number 7, you can find out the data. So what is the function? So you are applying the plus 1, incrementing your data value plus 1 to store that particular record, right? So this is my logic. So you can say this is the main function. So here, what is my main function? So this mode with 5 is the main function. So this is known as hash function, which is sum of the characters mode with the table size. Okay, now using this hash value, we can search for the string. This seems to be great way to store our directory. Okay, or you can say store a particular dictionary. Now, therefore, the idea of a hashing seems to be a great way to store a pages of key and value in a table. So I have some key with me, I have some values with me in the table, and according to this key and value, we can store it or we can find out into the hash table. Now, problem with hashing. So, what is the major problem where you can store? Where you want to try to store this kind of record. So the method discussed seems too good as we begin to think more about the hash function. Now, first of all, the hash function we use, that is the sum of letters. That is a bad one. That is our wrong idea. So now in case we have a permutations of the same letters like ABC in BAC or maybe in a CABY, right? So the set we will end up with the same value for the sum and hence the key. So what is the value of B? That is equals to 2. A value equals to 1 and C value equals to 3. So the answer is equals to 6 only. So in this case, it is going to store at the 6 mode 5. So 6 mode 5. So answer equals to 1. So it is going to store at the 1 number index, right? If we have ABC, then also the answer is equals to 6 more 5 equals to 1. So in this case, the string would hash into the same location. So creating that we call as a collision, right? So this is the thing, like at the same location, we are just trying to find out, we are just trying to store the same key value at that particular location. Okay, you can say ABC is stored at that one number location. BSA is going to store at the same location by applying this hash function. Okay, so you can say there is some collision. Like, how can I find ABC or BAC? So that thing is going to known as the collision. Now, how do we pick a good hash function, or how do we deal with the collision? Right, so that is the major problem with hashing. So picking a good hash function is key to successfully implementing a hash table. So there is no any chance to collide something or to collision, right? So what we mean by good is that the function must be easy to compute as well as it can avoid the collision as much as possible. Okay, so For that particular thing, we must have to define some properties of the good hashing function, which is equals to low cost, determinism, and uniformity. Now, binary search find a value in a log n, so hash function must cost less than this. Then it is known as low cost. Otherwise, our binary function or binary search technique is good. Okay, but we are trying to find the better way from that binary search. Now, determinism, that means same hash value for the same input. Like if I'm applying ABC 10 times, then it may be for a same hash value. Now, uniform hash value maximize the number of collision. Okay, that means uh, uniform hash value with us, then it will minimize the number of collision techniques. That means there is no chance, or you can say less chance to collision. Now, first method is the division method. Now, this method divides a key k by a prime number m and then uses the remainder which is obtained by us. Uh, you can write your enrollment number for the attendance purpose and then we'll resume our session one more time.
હેલો મેડમ.
Yes, Shelby.
મેડમ મારો લખાતું નથી, સેન્ડ નથી થતું.
Okay, ha.
એટલે મારે
Okay, you can say your number. I'll write your number over here.
1911
Hmm. 60
6010
70.
26.
Okay, Shelby. And next, who said? Okay, so here how we can do it. So you can say like if we have a key with us, that is key mode m, that means we have some number as a prime number, okay, which we had defined first, okay, then and only then we can do it. Now, so what is a hash? So this hash function is applied into this 1 2 3 4 5 value. Okay, so this is my key. So key module mode 95, and the answer is 90. Okay, now next how we can do it. So second, so this is my first method, that is known as a division method. Okay, so here what we are trying to do, we are just trying to apply into the mode wise, like key mode m value. Okay, so in examination, how we can avoid this collision. So first technique is division method. Second is the mid square method. Now what is mid square method? So from this given value, first we are trying to extract some middle bits. So square the value of the key. So extract the middle r bits of the result. So if k equals to 1, 2, 3, 4, 5, right, then we must have to square of that k value. Okay, so what is the answer of this square? So 1, 2, 3, 4, 5 multiplied by 1, 2, 3, 4, 5. So answer is equals to 1523999025. This is the square of my particular key value. Okay, now from that middle three bits I am extracting, that is 399. Okay, and which are the middle two bits of that particular date, that is 39. Okay, so this is our value, or at that place we can store our value. Okay, so this is known as the mid square method. Now in this mid square method, what we are trying to find, first we are just trying to define, or we are just trying to discuss the particular middle value of a given number. Okay, now what are the middle values? So that middle values are, you can say the 39 from after completion of square to that number. Huh? So square of that number is equals to, you can say the 152399025. Okay, now if I am giving you the number 1234, so what is the square of that 1234? That is 1522756. Yes, so in that case, first find out the middle value of that number, that is middle 3 bit, that is known as, or you can say 215222756. Okay, so middle 3 bits are 227, and from that 227 we are just trying to find out the last two digit of that three numbers, that is 27. Okay, so that are the technique of my particular, or you can say the mid square method. Okay, now the last one, that is folding method. And in this folding method, what we are trying to do? So in this folding method, if we have a time, so that we can go towards the next method also. Okay, now divide the key value into a number of parts. So now into a number of parts, that means from K1, K2, K3 up to Kn, we are just trying to divide it into the different parts of values. Now where each part has the same number of digits except the last one. Right. Except last one, we have to take the same number from that digits. Okay, now add that individual parts. So from that, we are just trying to at that particular individual paths, and the hash value is obtained by ignoring the last carry. Okay, so here our number is 1 2 3 4 5. So divide it into the each and every pair of the same number of digits: 12, 3, 4, and 5. What is the answer of this? That is 51. Okay, yes. So that 51 is going to work as the key of my, or you can say the hash value of my particular data of 1 2 3 4 5. Okay, so this is the value or hash value. So this is a hash function. So what is hash function? So first we are trying to divide it into the number of paths, then we are adding it into the particular format, and then we are trying to divide it into the or you can say ignoring the last carry. Okay, now what is the next method? The next method is the multiplication method. Now in this multiplication method, what we are trying to find? So we can choose a constant a such that our zero, sorry, our a value is less than a, as well as this a is also less than 1. Okay, okay. So this a is greater than 0 and less than 1. So 0 less than a less than 1. Now multiply k by that a value. Extract the fractional part of multiply ka and multiply the result by m to take the floor value. Okay, now say for example first we have to find the floor, but before that we must have to multiply our key with one particular a value, and then we need to mode it with 1. Okay, so mode with 1, that means what? Like if we are trying to find that particular data, we must have to mode, because this is you can say our next functioning value. Okay, this is our hash function, you can say. Okay, but make sure that our e is greater than 0 and less than 1 only. Then and only then we can do it. Otherwise, we cannot do it. Okay, and you can say one of the writer, or you can say scientist or author, defined that that defined as the A value, which is bestly choice of my A, is known as, you can say, the 0.6180 value, which is taking at the A. Okay, so we can take this also, this one, because it is given in the question. That's all. So the hash of 1 2 3 4 5 is equals to, take a floor of key. My here my key is equals to 100. This is my 1 2 3 4 5 of key. Mode, we have to mode it with m. Then this is the a, which is greater than 0 but it is less than 1. Okay, now what is the multiplication of this? So multiplied, after multiplied this will be the, you can say, the answer of the multiplication. Then we have to mode this value with 1. So whatever the remainder is, we have to store it over here in the answer. And after multiplying with this 100, we have to take that value's floor value. Floor, not the ceiling value. Floor, that means for 53 only. Okay, so at this location, this is my hash of key. Okay, so at this place, I can store it into the table. Okay, now what is the algebraic method? Okay, so suppose we need to store a dictionary in a hash table. Okay, before we'll start with this, is there any doubt in this? We had discussed you can say how many functions of hashing. First is the division method. We have to take the mode with the m value. Second, mid square method. We need to find out the middle one value of that particular key, and then we have to divide it into the find out the 3 bits, and from that we can take the middle 2 r bits. Then folding method, divide it into the parts, add it and ignore the last key if there is. Now multiplication method. So define your key. Take one a, such kind of my a is greater than 0 but less than 1. Okay, and as Knut has defined, like the best choice of my capital A is equals to 0.61, best choice. Okay, if they were not given 0.618033. Digits are also there after this, but we are just trying to taking this on. Okay, if that is not given in your question, okay, you can take this also. Okay, but that is predefined value. Okay, so in this method, any doubt till now? Okay, so next is algebraic method. So suppose we need to store a dictionary in a hash table. So a dictionary is a set of strings and we can define a hash function as follows. How we can define it? So assume that S is a string of length n and S equals to S1, S2 up to Sn. So what is the hashing of that particular S or that particular string? So hash of S1, S2 up to Sn. What we are trying to find? So S1 plus P. What is P? So where P is a prime number. Obviously each string will lead to a unique number, right? So that prime number, that means if we are adding it with the another number, it will lead to a next new number, then p square, then s3 plus p cube, then s3 plus p raised to, s4 multiplied plus with the p4, p raised to 4, up to p and minus 1 and sn. Okay, so using this we can find out the particular hash of the particular string also, right? As according to the, you can say the index values as well as for the dictionary purpose, because in the dictionary we are trying to store the string, that's why. Okay, now collision. So how we can resolve this collision? Okay, so we have only two techniques with us that is related with our collision. First, it is difficult to find a perfect hash function. That is a function that has no collision. Now, one problem with that hashing is that it is possible that two strings can hash into the same location, right? It may be possible. So how we can resolve it? So if two keys hash to the same index, the corresponding records cannot be stored in the same location, right? So for that we have to generate the different location. So if it is already occupied, then we must find another location to store the new record and do it so that we can find it when we look it up later on. Okay, so if the one value stored at the same location, second one we cannot store. But how we can do it? So there are some, you can say different two techniques, chaining and open addressing. The first, that is open addressing. Open addressing hash tables can store the records directly within the array. Okay. Now, a hash collision is resolved by probing or searching through alternate locations in the array. Now, the problem is sequence, right? Until either the target record is found or an unused array slot is found, which indicates that there is no such key in the table, at that place you can store it. Okay, if collision is happening. Okay. Now, linear probing looking for the next available location like I plus 1. So if I'm storing the record in a particular location at the number 2. So if there is some collision happening in the location number 2, then direct next access I'm trying to find. If it is free, then next value which is going to stored at the same location, now it is going to transfer in the next address. That is our linear probing. And what is quadratic probing? So quadratic probing, same as probing, that means we are trying to find the next free slots for resolving that collision. Okay, so quadratic probing same as a linear probing, except we look for available positions like I plus 1, I plus 4, I plus 9. So from the hashed value I. Okay, now for the chaining, each slot in the array references a linked list of inserted records that collide to the same slot. Okay. Now insertion requires finding the correct slot and appending to either end of the list in that slot, or deletion requires searching the list and removal. That means either they can find from the available list of that available slots, or they are just trying to delete something and search the new list. Okay, so how that chaining is happening? So key index and key values pair. So we have a John name with us. There is no free slot, so where we can store it? So Lisa and Smith are stored at the one number location. So here we have a one number location. Okay, so now after storing this, if I want to store this John Smith at the location number 873, and this Sandra D also wants to store at the same location. Okay, so how we can store the two records at the same place? So first who will come? So John. So it will going to store at this location. Okay, but if the direct next record is trying to store at the same location, what it will do? So from the chaining, it can find out the particular location and it can store that new location. And I'm providing that sequence chaining to that particular location, like you can store that values over here. Okay, or the next value which is trying to store at the same place, that value is going to store over here. So I have that address, you can directly connect to that address. Okay, clear? Yes, so you can if you have any doubt, you can ask me, otherwise you may leave the session.